Confidence interval for the population parameter mu when the sigma square is unknown. That is actually the second case. पहले हमने जो केस डिस्कस किया था उसमें भी हमने पॉपुलेशन पैरामीटर के लिए कॉन्फिडेंस इंटरवल डेवलप किए थे, लेकिन उसमें पॉपुलेशन वेरिएंस नोन था हमारे पास. इस केस में हमारे पास पॉपुलेशन वेरिएंस जो है वो अननोन है, एंड दैट इज़ द मोर रियलिस्टिक कंडीशन बिकॉज व्हेन वी आर गोइंग टू यूज इट इन अ प्रैक्टिकली फॉर्म then we do not know the variance of the population. तो ऐसी सिचुएशन में हमारे पास क्या होता है कि हमारे पास एक डाटा होता है और उससे हम उस पॉपुलेशन वेरिएंस को एस्टिमेट करते हैं बाय यूजिंग दिस सैम्पल डाटा. तो दैट इज़ द मोर रियलिस्टिक एक्चुअली अप्रोच कि जब हम कॉन्फिडेंस इंटरवल डेवलप करते हैं पॉपुलेशन मीन के लिए तो जनरली हमारे पास पॉपुलेशन वेरिएंस अननोन होता है. तो जब एक्चुअली आप प्रैक्टिकली यूज़ करेंगे इस कॉन्फिडेंस इंटरवल को तो ये ज़्यादा मोर रियलिस्टिक कंडीशन हमारे पास होगी. So how we develop the confidence interval for this type of condition? So let x1, x2 be the random sample from the normal distribution with mean theta and variance sigma square, and we are interested to find the confidence interval for the theta and keeping in view that sigma square is not known. So assuming s is the standard deviation of this random sample, then the random variable t is defined as, now I am going to define the random variable t, that is t is equal to x bar minus theta over s over under root n. Because we do not know the sigma square, so we use its estimate, that is s square, and basically it is follow the t distribution with n minus 1 degree of freedom. It is already known that, so how this follow the t distribution, I just explained this one. It is already known that the ratio of the standard normal distribution and the chi-square distribution with n minus 1 degree of freedom follows the t distribution. ये हम प्रूव कर चुके हैं इब्तदाई मॉड्यूल्स में जब हमने डिस्ट्रीब्यूशंस की प्रॉपर्टीज़ को स्टडी किया था, तो उसमें हम ये प्रूव कर चुके थे. आई जस्ट रिकॉल दैट रिजल्ट. सो इफ z is a standard normal with mean 0 and variance 1 and y is a chi-square distribution with n minus 1 degree of freedom, and we have already proved that, then the ratio of this basically is a t distribution. So ratio of z divided by the y and divided by its degree of freedom whole under root, and basically it converted to x bar minus theta after simplification, that is s over under root n. So thus the random variable t is our pivot value, and using thus t is our pivot value variable, and using the definition of t p n, the 1 minus alpha confidence interval for t is as, that is the probability on the same line which we have already did in the previous case, that is minus t alpha by 2 less than t alpha by 2, and that is 1 minus alpha. So we can write it as minus t alpha by 2 less than x bar minus theta over s over under root n less than t alpha by 2, and that is 1 minus alpha. Again we are going to solve this inequality for the theta, and after simplification I just write down the result, that is probability x bar minus t alpha by 2 into s over under root n less than theta less than x bar plus t alpha by 2 into s over under root n, and that is for 1 minus alpha. So one can say that this one x bar minus t alpha by 2 into s over under root n, and x bar plus t alpha by 2 s over under root n, or the confidence interval for the population parameter theta with sigma square is not known.